Okay, so this is section 4.6, and we're going to be talking about the mean value theorem. And the first thing that we're going to talk about is actually Rolle's theorem. And so what Rolle's theorem says is we have f, which is a continuous function on a closed interval that is also differentiable. Then at some point, c, the derivative of c is going to equal 0. Okay, so what it essentially is telling us is that somewhere between A and B, those 2 points, there's going to be at least one point with a horizontal tangent line, and that's when we get our derivative equal to 0. Now, it has to be continuous and a closed interval. You'll notice with the two pictures I have here that the horizontal tangent line doesn't exist since I've got two different values here. And whenever we have those sharp points, it also does not have a horizontal tangent line. Okay. So if I'm looking at this first example, the first thing I need to check is I need to make sure it's continuous and I need to make sure that it is differentiable. So in this case, I have a polynomial. So check, is it continuous? And the answer is yes, because this is a polynomial. And then my second check is it differentiable? And the answer is yes. Okay, so knowing those two things, we can solve this problem. So the first thing that I'm noticing is we're going to need an interval since they didn't give me one. And to do that, I'm going to actually factor my original function. Okay, so if I factor f of x, the first thing I'm noticing is I can take out an x. Which will leave me with x squared minus 7x plus 10. And then I have a quadratic in my second parentheses, and I can factor that. So I'm going to end up with x minus 2 and x minus 5. All right, so if I were to set each of these pieces equal to 0, I would get x equals 0, 2, and 5. Okay, so my interval is going to be between 0 and 5. Okay, oh, and that should be a bracket as well. Okay, all right, so we are going to find a point where the derivative is equal to 0. This is exactly like finding the critical points, which we've been doing. So first we need the derivative. So I'm going to end up with 3x squared minus 14x plus 10. So I tried to factor this, but unfortunately you can't. So that means we're going to need to do the quadratic formula. Okay, so negative b plus or minus the square root of b squared minus 4 A, C, ooh. All divided by, whoa, 2A. Okay, so I can simplify this down, and I'm going to get 14 plus or minus square root of 76, all divided by 6. Now I can break the square root of 76 down, and it's going to give me 14 plus or minus 2 square root of 19, all divided by 6. And then since I have a 14, a 2, and a 6, those are all even numbers. And therefore I can divide by a factor of 2. So I end up with 7 plus or minus square root of 19, all divided by 3. And if you plug those into each of those into the calculator, you're going to end up with x is about 0.88 and 3.79. Okay, so let's do another one. Okay, so first question, is this continuous? And the answer is yes. Is it differentiable? And the answer is yes. Okay. All right, so we are going to need to do the chain rule for this because we've got a 2 inside next to the x. Okay, so essentially, I'm going to say that my u is going to be 2x, and the derivative of that is 2. So then I can easily take the derivative of sine u. The derivative of sine u is negative cosine u. Okay. And it's not negative, it's positive. Come on, eraser. There we go. Getting too excited. Okay, so I'm gonna replug that in. So cosine u du is cosine 2x times 2. So I'm gonna end up with 2 cosine 2x. Okay, so now I'm gonna set that equal to 0. Oh, I thought I was gonna change colors. All right, so the first thing I'm going to do is I'm going to divide by 2, and that's really not going to matter because 0 divided by 2 is 0. So then I'm getting the cosine of 2x equals 0. So the thing you need to ask yourself is, where is cosine equal to 0? And the answer is at pi over 2 and 3 pi over 2. So we're getting 2x equals pi over 2 and 2x is 3 pi over 2. Now I'm not going to care about one of these solutions, and I don't know if you realize which one it is, but we have to divide both of these by 2, and we'll end up with x equals pi over 4, and x equals 3 pi over 4. Okay, so I don't care about this second one. And the reason why I don't care about this second one is because it's not in my original interval that they gave me. They gave me an interval of 0 to pi over 2. So essentially it's like the first quadrant of your unit circle. So this is not in my interval. Okay. Okay, so we have the mean value theorem. So the mean value theorem is another way that we can figure out when the derivative is equal to that one special point, okay? So what we're going to do is we're going to take our interval and we're going to plug into our original function, b minus a, and then we are going to divide that by b minus a. And that is going to be the same as taking the derivative and plugging in that c point, okay? So let's go ahead and do the next problem. Oops, I think I went backwards. Yep, I did. Okay, so for this next problem, what we want to do is we want to first do our checks. Okay, so is this continuous? The answer is yes. Is it differentiable? Can I take the derivative? And the answer is yes. Okay, so this time we are going to use our Rolle's theorem, our mean value theorem, to do this problem. So let me write it down first. And for some reason, I always forget the subtraction sign. I don't know why. Okay. So what we are essentially going to do, this -2 is A, and this is B. So we're going to plug in f of 2 minus f of -2 all divided by 2 minus -2. Okay, so if we plug in those values, we're going to get 11 minus -9 all divided by 4, which is going to give me 5. Okay, so that is telling me what the derivative is going to need to be equal to. So now I'm going to take the derivative. So we're going to get 6x squared minus 3, and we're going to equal that to 5. So we're going to get 6x squared is 8. So we're going to then divide by 6 to get x squared is 4/3. And then we're going to take the square root. Okay, so as you know, we don't like our radicals in our denominators, so we can rationalize this by multiplying both the top and the bottom by square root of 3. And if I do that, I'm going to end up with 2 square root of 3 all divided by 3. Okay? All right, so let's do another one. Okay, so for this example, let's do our checks. And when I'm doing my check, I know that this is not continuous or differentiable when x equals 0. And that makes sense because I have a fraction in this case, but it doesn't matter because 0 is not in the interval of interest in this case. So it's not continuous or differentiable at x equals 0. But that's not in my interval, so I don't care. Okay? All right, so we're going to set this one up just like we did the last one. We're going to do all right, so we're plugging in 3 to my original function minus 1 plugged into my original function, all divided by 3 minus 1. And if we do that, we are going to end up with 2/3. Okay? All right, so now I'm going to go ahead and take my derivative. So before I do that, I'm going to write f of x as x plus x to the negative 1, just because it's going to make it easier for me to take my derivative. So it's going to give me 1 plus 1 over x squared. Nope, it's minus. Come on, eraser. You hear my cat? She's crying. Okay. So the negative 1 is going to come down, and then I'm going to subtract 1 from here, which is why I get a negative 2, and I'm going to drop that down. Okay, so what are we going to equal that to? We're going to equal that to 2/3. Okay, so I start by subtracting 1. So I'm going to end up with negative 1 x squared, 1 over x squared equals negative 1/3. And then I'm going to cross multiply, which is going to end up giving me 3 is equal to x squared. And then I'm going to take the square root. Now you'll notice when I take the square root of 3, it's going to give me plus or minus the square root of 3. But the negative square root of 3 is not in my interval because my interval is from 1 to 3. So my only answer that I care about in this case is x equals the positive square root of 3. All right, the last thing that we're going to learn about in this video is Newton's method for approximating the zeros of a function. So in this case, what we're going to do is we are going to make some initial estimate, x1, that's really close to the c value, and then we're going to use this formula. Okay. So every time that you do this, it's called an iteration. So let's go ahead and knock this out with an example. Okay, so we are going to calculate 3 iterations. That means I have to do this 3 times for the function f of x equals x squared minus 2 using a starting value x1 equal to 1. Okay, so I need, before I do this, my derivative, which is 2x. Okay. And we're starting with 1. All right, so I'm going to write my formula down first. So to find x sub 2, what you're going to do is you're going to take x sub 1 minus that initial value plugged into your original function divided by the initial value plugged into the derivative. Okay, so for this first one, you're going to end up with 1 minus negative 1 half, which is 3 over 2. Okay. These ones are going to get a little bit yucky, so I would suggest using the store feature on your calculator if you have that. So what you can do is you can actually store values for x, especially when they're very long, yucky decimals. If not, you need to make sure that you use at least 5 or 6 decimal places, but I would encourage you to use the actual number, not a rounded version, because you could make some mistakes. All right, so x sub 3. You're going to take x sub 2, and you're going to subtract the value of x sub 2 plugged into the original function and into your derivative. So this one gets a little bit yuckier. The next one we're going to use. So you're going to end up with minus 1/4 divided by 3, and you're going to get 17 over 12. So what I did was I stored 17 over 12 when I plugged that into my original f of x and to my derivative, because I found when I did not do that, I got the incorrect answer. Okay, so this next one, we're going to take x sub 3. Okay, so I'm going to get 17 over 12 minus 1 over 408. Got to be really careful with this, because I definitely had to plug this one in a couple of times because I made some mistakes and I tried to go too fast. And there we go. So we're done with that one. All right, let's do one more. So on this next one, I also use the store feature again, because I quickly started getting some decimals. Oh, okay. All right, so let's go ahead and find the derivative. Which is going to be 6x squared plus 2x minus 1. Our initial value is negative 1. Okay, so we're again doing 3 iterations. So I'm going to go ahead and find x sub 2, which is x sub 1 minus f of x1 and I'm going to get -1 minus 1/3, which is -4/3. So then x sub 3 is x sub 2 minus f of x sub 2 divided by. Okay, so -4/3 minus -17 over 27 over 7. All right, so I got a pretty yucky decimal. So what I then did was I stored this value as my x, and then I used it to plug in to do the next iteration. Okay. So x sub 4. Okay, so this one, if you get it plugged in correctly, is that. All right.